All right, so in this lesson, we are going to calculate side lengths and areas. So calculate side lengths and areas associated with right triangles. So this is very important. They're right triangles associated with right triangles and squares made from their side lengths. So associated with right triangles and squares made. You'll see what I mean. So before we do that, we need to label the parts of a right triangle. So first thing you should do is label the right angle. This is the right angle. This is the right angle. Directly across from the right angle, these are like side, 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 right? This side is called the hypotenuse. Okay? These two sides are legs. Leg 1 or leg 2, doesn't matter. They're just both legs. Leg, 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 leg. The hypotenuse across the side across the right angle. The longest side. I'm going to put that too. This is always going to be the longest side in your right triangle. Longest side. So maybe I should do something like that. No, I think it'll be fine. The longest side. It's called the hypotenuse. This will always be C. I will put that in a different color. This will be C. And these two will be A. So A equals the leg and B equals the leg. It doesn't matter if that's A or that's B or that's A or that's B, as long as the A and B go with the legs. So C is the hypotenuse. So even on this one over here, this is we start with our right angle, our 90-degree angle. And directly opposite of it is our hypotenuse. Hypotenuse. And then we have our two legs. So leg and leg. Don't forget that we have to label the A, B, and the C. So hypotenuse will always be C, and then it doesn't matter. This can be A, and this can be B, this leg and this leg. All right, so if I were you, I would go ahead and do all of these. And then, then check them with my notes or with this video. So give me 1 second and they should show up. All right, the Pythagorean theorem. The Pythagorean theorem is a squared. I'm going to write like this. A squared and then plus b squared, and we will get c squared. But what does that mean? A squared plus b squared equals c squared. Well, let's work on this. Let me show you. We have a right triangle. I can write that a little bit better. So this would be C. This will be A. Remember, A and B are like interchangeable, right? As far as which one's a leg, it doesn't matter whether this is A or this is A right here. And then we have B. So I'm going to give, I should put like that. Okay. So if A is too long, then it's too long. Like, you know what I mean? Like A can be too long and A can be too short. B can be too long and B can be too short. Like if you make B super like longer here, then it just wouldn't fit. Same with C. So A, B, and C can't be any numbers. A, B, and C cannot be any numbers. I'm going to show you, but they can be certain numbers. So I'm going to give you some numbers that work. A will be 3 units long. B will be 4 units long. And C will be 5 units long. These are the perfect length to make a right triangle. I'm going to show you what sense this makes, okay? So you see this side right here, this leg, I'm going to use it to make a square. Oops. I can do a little better. Square here, square here, square here. Or side, side, side. So I want to make a square here. Ooh, what was that? Okay, square here. Side here, it makes a square. It looks kind of rectangular. Maybe I could do a little better. Okay, and I'm gonna do my best to make a square with this side length right here. See, oops, already messing up. So maybe like that, like that, like that. I almost did it ish. Okay. So if this side length is 3 and this is a square, so this is 3 units long, this will be 3, this will be 3. Same with this. So if this length is 4, this will be 4 units, this will be 4 units, this will be 4 units. And for this square right here, if that side length is 5, that means each side length is 5 units. So I'm going to show you something. So 3. So that means it's like 3 units long, right? So you can see 1, 2, 3. Okay. You can see that it's 3 units long. I'm going to do the same thing here. Right? So if I do this, we can see the area. The area of this square is 9, right? Let's do the same thing with the 4. So here, so it's 4 units long. And then we'll do it here. Okay, so right here. Remember, these are supposed to be squares. My drawing's not perfect at all, but these are supposed to be squares. 4 times 4 is 16. You have 16 squares. The area is 16. Let's do one more. So the 5. 1, 2, 3, 4. I can do it a little better. Those are a little noticeably wrong. Okay, so I can go like that, that, and that. And 5. 1, 2, 3, 4. All right, we'll wait a second. So 1, 2, 3, 4. Let's see if I can do this. 1, 2, 3, 4. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the area of this square made with this leg is 9. Well, I guess I made it a little smaller. 9 units squares. 9 units. 9 square units. This one here is, or maybe I should just make it a different color. That'll be easier. So this one is 9 square units. This one is 16 square units. And this one is 25 square units. So if you notice, this leg, this square from the leg will equal the 25. So 9 plus 16 is 25. So if you add the a squared 3 times 3, if you do 3 times 3 and you add 4 times 4, you get 5 times 5. So let's write what that means a little bit more. So, I'll go back. So what is true for the areas of squares made by each side? So if you add the areas a squared and b squared you get the area of the large. You'll get the area of the large square.